Welcome everybody to the APEA and the APEA Eastern Branch webinar and Winter Meeting 2021. We have a couple of things to run through before we start the presentations, but could you please, as Alex said, could you please mute your phones and perhaps also have something handy for your kids or pets if they are around. After this webinar, we will hold our AGM, which is for the Eastern Branch members only. You will have a separate login for this. All you others can then go home. For health and safety, we can assume that you are in a safe environment and that you've located your exit and muster point. It's not our responsibility today. So for those of you who have not joined us before, just a little bit about the APEA. We are a UK-based organization. We were founded in 1958 with a worldwide membership. We focus on the technical and the scientific side of the industry, what goes on below and above petrol station forecourts. So our members come from the retail petroleum industry, and they are people who are involved with the design, the construction and operational filling station, and obviously includes regulators from both national and local government and authorities, as well as the oil companies and equipment manufacturers, suppliers and service organizations. But the organization was originally founded by the regulators all those years ago. And we maintain the principles of those founding members. So the APEA also runs training courses and provides technical advice and holds also an annual conference, which has a gala dinner and awards. This is scheduled for November 21 next year, which we hope to run. And Alex will probably say a few things about that a little later. I do urge you to go to the APEA website, have a look at it. We produce the Blue Book, which is like the industry Bible, gives fantastic guidance if you're in this industry, wherever you are in the world. We know that it has also been used in out of Mongolia. In addition to that, there is the Bulletin, which is our quarterly publication. And there is also a yearbook, and all of that you get for free. So please go to www.apea.org.uk. So if you have any articles you'd like to publish, please send those through to the APEA. Brian Hum is our editor, and Jane Bardell, our business manager, or myself or Alex, and we will take care of it for you. I also would like to say a thank you to our events committee, which is Peter Roll, our chair, who is actually retiring this year. And we say a big thank you to Peter, and Jamie Thompson, Andrew Olive, and Simon Smeaton, Alex Boudry, and myself. And but I would also like to say a very special thank you to Alex and Mel Fitzsimmons, our digital marketing specialist, who's helped in setting up this great event together. I would also like to extend a warm welcome to our affiliate association, the SPT Association, who are covering the Nordic countries, and many of their members are joining us here today. So welcome to you. Likewise, if you have similar like-minded organizations in your country who would like to reach out to us, please make contact with me. So we should aim to stick to the agenda and the timing. And for the presenters, please check your watches. For the audience, you can submit questions by clicking on the chat box, and we will do our best to have them answered. Please keep them short, and my colleague Alex will endeavor to get you a reply. If you must leave the room, please feel free to do so. It's an open door for re-entering. And as we said, please keep your mics muted and camera off. You can send your messages and pertinent questions, etc. So the Eastern Branch Committee and the speakers presenting do this voluntarily and give of their own time to provide this important information and the technical presentation for you and your organization. The views of the speakers are their own, and the APEA does not endorse the products or the views. We conduct the matters in a business-like manner. Nothing is personal, and we do hope that you will show your appreciation when you receive a little response form from us after the event, telling us how you felt we did. For many of us, this is the first event, and yeah, it's a great education. So on that basis, I would like to hand over to my colleague, or perhaps I do so, Alex, I'll just go to the agenda. So I think you all have the agenda for today. It's straightforward. I don't think read through it all. We started at 2. We aim to end around about 4 o'clock-ish. So some very interesting topics. And on that basis, I will hand over to my colleague, Alex Boudry, who will give some updates from the APEA National Council.
Hello all. My name is Alex Boudry. I am, for those that don't know me, I'm the Eastern Branch representative on the APEA National Council. So a little bit about me. My day job, I'm the general manager of a company called PFS Fuel Tech. We're suppliers of fueling equipment, and I've been in the industry for 15 years. PFS Fuel Tech supply a range of parts to fueling installations across forecourt, fleet refueling, marinas, critical power, railway, and road tanker spares. So I thought I'd give, because we've got a lot of visitors today, I think 116 people in the meeting today, so it's a good turnout. So thank you everybody for joining. I thought I'd just give you an intro to the APEA. Anton's done this briefly, so I'll run over it quickly. So we are a UK-based organisation drawing membership from all quarters of the petroleum industry. And what's unique about the APEA is that we represent all sides of the industry and provide a forum for debate and generation of technical guidance. So we're not an industry association that kind of focuses on the commercial side of the industry, or the forecourt convenience side. We're more to do with the technical aspects of fueling. So we are quite unique in that regard. And the organisation structure is that we have 8 regional branches. This meeting today has been organised by the Eastern Branch, but we have a national and international attendance today. So if you join the APEA, you are assigned to your local branch when you join. Membership benefits include being part of an influential industry technical organisation. We publish a quarterly magazine, a yearbook. The APEA runs training courses on various aspects of petroleum storage and forecourt retail. And it's also a good place to network and meet and discuss points with other people within the industry. Membership is relatively inexpensive, £50 a year per individual, or £75 a year for a corporate membership. I thought I'd run quickly through the organisation structure. So the APEA Council is made up of elected APEA officers: the chairman, the vice chairman, the immediate past chairman, the secretary, treasurer, the editor of the magazine, the 8 representatives of each branch, of which I am the representative for the Eastern Branch, and up to 4 other elected members these people make up the APEA Council. Within that council, there's various committees that look after different aspects, and everything we do is intended to add value to our membership. So the technical committee will look at standards, regulations, and also answer questions that members may have on the technical side of things. The training committee sets up training events, publications and events. Electronic comms and branches is all pretty self-explanatory. Some of the publications that the APEA publishes, the one that most people know is the Blue Book. or to give it its full title, the Guidance for Design, Construction, Modification, Maintenance and Decommissioning of Filling Stations. This is the go-to reference guide for anyone involved in installations involving petrol. And if you don't know this book, I urge you to seek it out. You can download a PDF copy from the APEA website. And if you're a member when the new version of this launches, which it does roughly every 4 to 5 years, then you also receive a free copy of this book, hard copy, as a member. Other publications that the APEA has published include a new electrical vehicle charging installations at filling stations book, and guidance on hydrogen delivery. So all of these are available at a discount for members at apea.org.uk. Just some other things that we're working on right now: digital training. So we're investing in professional online training courses. These will be available. The first one of these will launch in early 2021 and will be titled Petrol Operators and Regulators for the Familiarization. So that's a good course for anybody that's involved in petrol station design or operation, or is a regulator, and again, launching hopefully early 2021. Some other things that we're working on right now: we've been contacted by the TÜV in Germany to collaborate on some guidance for multi-fuel station, including hydrogen. And we're still doing ongoing face-to-face training. It's COVID safe with reduced numbers. Some of the courses we're doing recently are bespoke training for fire services and for large retail forecourt operators. So I urge you to get involved if you can. You can help the Eastern Branch Committee or your local branch committee. It's a small time commitment, and it helps to determine what our events look like, and you can help shape the future of the industry. And you can utilize the APEA. So we exist for our members. Contact me if you have anything that you'd like me to discuss with the APEA Council, or things that you think we should be thinking about, or you can contact the APEA via the website.
Fantastic, thank you both. So good afternoon everybody. My name's Clare Scawthorn. For those of you who don't know me, I'm the Petroleum and Alternative Fuels Group Manager at London Fire Brigade, and I have the very lucky job of running a team of inspectors who regulate all of the petrol filling stations across London, and I'm also very fortunate to be able to take part in a number of our national groups, which includes the APEA. And I also am the current chair of our Petroleum and Enforcement Liaison Group, which is a working group of the HSE. So today I'm just going to give you a quick regulatory update on what's going on in the field, and hopefully I'll have time for some questions at the end. There we go. So first up, the review of the petroleum consolidation regulations was released a few months ago. When the PCR, as we like to call it, was introduced in 2014, within the regs, there was a legal requirement to review this piece of legislation at 5 yearly increments, with the intention of establishing if the regulations had achieved what they had been set out to do. That being, it was designed to consolidate and modernise the petrol storage legislative framework, reduce burden on industry and regulators, and maintain safety standards. So the HSE carried out this review back in 2019, and they did this by holding surveys and a workshop which was held at the Energy Institute. So the findings of this were that there are some issues in terms of the interpretation of the legislation and the general application. However, overall, they were achieving their aims. But the outcome of it was to provide a couple of recommendations to go forward. So the first two were designed for the HSE to pick up, and these are actions they are looking into. The first is to review the fees and the process behind this. So some members of industry questioned the purpose of the fees and what they received back from them. So the HSE will be doing a piece of work into that. The second recommendation that the HSE will be actioning is a review of the MOD's enforcement position. So the Ministry of Defence were not covered by the previous petroleum legislation, but they self-regulated in line with them. And MOD sites are now subject to the PCR, but have not been named as a regulator. So they're taking that piece of work away to have a look at how that may be resolved. The next 3 recommendations were given directly to PELG, and they are that we are to create a risk-based inspection regime which can be used and applied nationally. Second was to review training in place for regulators. As part of that work will involve looking at a competency framework for inspectors to be able to achieve. And lastly, we were tasked with reviewing guidance. And this will see us doing a gap analysis on what is currently covered, what isn't, and what needs to be created to provide clearer guidance for industry and for regulators. So this ties in very heavily into the current workload of PELG on what we will be doing over the next few years. And to do that, we've created a high-level strategy. And obviously the first thing we'll be looking at is to deliver these recommendations. And we'll be creating working groups to be able to do that. So you may be contacted by some of your representatives, and that's especially for the regulators, but also for industry, to help format that and how we're going to move forward with this. We'll also be identifying emerging risks and developments, and that's to steer our guidance, such as the impact of alternative fuels, and also the potential increase in disused tanks and the guidance that may be needed in respect of that to make sure the process is done safely and people understand what they're expected to do. So I'm sure most of you have seen this over the past couple of weeks, but the government have also made some announcements, and that's in relation to bringing the ban on petrol and diesel vehicles forward to 2030. Now, as far as we understand this, it's only for the pure fossil fuel vehicles. This doesn't currently include hybrid vehicles, but this also will likely see an increase in the rollout speed of electric vehicle charging equipment and the emergence of any other alternatives that we may see. So this ties quite nicely into guidance, and as Alex mentioned in his presentation just now, one of the guidance documents that we've had released recently was guidance that's now available via the IET and the APEA for its supplement to the IET's code of practice for installing EV charging equipment, and this is with a focus for petrol forecourts, which hopefully will help us to make this transition safer as we all try to make our way through this. So that's just a short, quick update on where we are in regulatory terms. Hopefully I've still got a bit of time, so if there are any questions, thank you for listening, and please do put them forward to me. I'll happily answer them.
Thank you, Mel. We don't have any questions come through on the chat. I would ask people, if they do have questions, write them down as they come to you. But I don't have any questions for Mel. Wonder if Anton does.
Well, for Claire, I do have a question.
Sorry, for Claire, sorry.
Yeah, it was concerning the competence of the of companies or people who are doing the installation work if they're doing it on a petrol station forecourt. Are there any concerns there?
Potentially, it'll all be taken on a case-by-case basis. The main advice that's going out there is, if you are going to be installing this type of equipment, is to make sure you're using competent people who understand, first and foremost, what their responsibility is and how to do that job properly, but also making sure of an understanding of the risks around them. So I'm sure there are many competent electricians and installers who understand how their equipment works and how they need to install that equipment, but it's also having that understanding about the environment you'll be working in, and if they're not used to working in a forecourt environment, it's really worth making sure they do some research and that their risk assessments and method statements take account of that.
Thank you. Any other questions for Claire? No? Okay, thank you very much, Claire. So
first slide, thank you. I've been asked to talk a little bit about European standards and Brexit. CEN is the organisation which issued European standards. It's not part of the EU, and the UK has left the EU, but not CEN. Now, there are other countries that are members of CEN which are not in the EU: Turkey, Norway, Switzerland, Iceland, and now the UK. So in addition, CEN has arrangements of cooperation with other countries, standard development. India is one. They take a lot of the work that we do in our standards authorities. European standards are an important part of ensuring manufacturers and regulators and consumers have products which are safe. According to the regulations, the national organisations of the following countries are bound to implement European standards in their own country, so that when a standard is issued, then we all have to accept it and we publish it. So all those countries that are listed there combine and use this. Not only is it used in these countries that has an obligation to use it, it's also used in many other countries. I've just today been speaking to people in Bahrain, and they use all the European standards. As Anton said earlier, they're also used in Outer Mongolia. So it's quite a worldwide acceptance of these standards. Next slide. As a matter of interest, we've already got tank standards for underground tanks and for above ground tanks. Anton, can you pull? Can you pull all those up? And if you look, we have on the right hand side, you'll see the photograph of above ground vertical tanks. This is a service station in the Nordic countries, where there's a lot of interest in putting above ground vertical tanks on filling stations. And we expect there to be some interest in other parts of Europe. They'll probably have to be fire resisting, but the first draft is out and we'll have a meeting early in 2021 to progress this. There are several other standards involving the petrol station forecourt. The underground pipe work standard has been in use for some time. We have a problem at the moment in the fact that some of the test liquids are not as available as they were, and they're looking at now producing a new test liquid. The other standards are already been published. The automatic nozzles, the metering pumps, 1 to 4, part 1 to 4, in the process of all the work has been done, and I expect that they will be published early next year. Thank you. And that's really all the update I have for that. There should be a slide about CE somewhere there, but it isn't. It's the UK CS marking for things at the moment. If you look at the CE marking, that's going to be replaced by UK CS mark, and that's going to have taken effect from the 1st of January 2021. Are there any questions?
Jamie, on the marking, as you put in the question, and that is, do you see any challenges in that sort of transition period then for UK companies? Time is rather short, and
not really. We still don't know exactly whether we've got a deal or not. We won't know right until the last moment. But I think all the work that's being done by the notified bodies and all the regulators and all the pump manufacturers and people like that have all been working quite hard in making sure that the equipment that they sell into Europe will comply with the requirements. That really it's a matter of just making sure marking is correct. The standards will remain the same, and that's what's a bit crazy about it, really.
Thanks, Jamie. In terms of questions, we've had a few requests to share your presentation, Jamie, because people are interested in those standards and understanding which standards apply to which products. So question number one, I'm assuming we can share your presentation.
Yeah.
And question number two, is there somewhere where all of these standards are listed? I'm assuming probably the APEA website.
Well, if they buy the blue book, they're all in there.
Oh, there you go. So the blue book, and also I think in the APEA yearbook as well. So
Yeah.
that's great. There's a couple more
So can I
questions.
just make a little promo add to Jamie, because he did specifically mention nozzles, and obviously on the ZVA nozzle, there is actually a data metrics. And so for both the regulators and the manufacturers, you can scan that and it'll actually provide you with all the certifications and technical documents you need for your file.
Okay. Question here from Graham Kenyon. Is it true that the UKCA mark will only initially be required where a notified body must be used to demonstrate the essential requirements of legislation?
Yes.
Yes. And will UKCS be equivalent to a CE marking?
Yes.
Yeah. Will markings on dispensers have to change to reflect the new standards?
Any new design, I believe, will, yes.
They will. Okay. Okay, that was all the questions. So thank you, Jamie.
Okay.
Anton, over to you to introduce the next speaker.
Fantastic. Okie doke. Good. Just a quick thank you to Alex and Anton for asking me to present today. Hopefully you'll find everything of interest. It's a fairly lengthy presentation, so I'm hoping I can squeeze it within the time period, so I'll crack on. So yeah, the title of the presentation, Clean Our Air with HVO. You may have heard about HVO. It is an acronym. HVO stands for hydrogenated vegetable oil. So let's just kick in a little bit more. Okay. So some bullets, if you like, what HVO is all about. So HVO, it's a liquid fuel. It provides net GHG CO2 reductions of 90% versus fossil diesel fuel. HVO is manufactured from 100% renewable and sustainable waste-derived raw materials. Importantly, it's accepted by UK legislation, road transport fuel obligation, which is basically all around reducing carbon dioxide emissions from road fuels, and also in the NRMM space as well. And it's certified independently by the ISCC as being a renewable and sustainable product. HVO is drop-in. It can replace mineral diesel fuel in all proportions as 100% fuel in itself, or as a blend stock, although here at Crown we are concentrating on the sale of HVO 100. No changes required in the engine. And importantly, I guess for the members on this webinar today, no changes in operational infrastructure. And indeed, HVO has a higher flash point. The flash point of HVO is above the 60-degree flammable cutoff. So from a safety perspective, HVO is much better. And certainly in terms of transport regs and ADRs and all of that sort of stuff, it's much simpler to move around and store, of course. HVO also gives significant reductions in noxious tailpipe emissions. When I'm talking about noxious tailpipes, what I'm thinking around is particulate matter, SOx, of course, NOx, NOx, carbon monoxide, total unburnt hydrocarbons. And that really links into the cleanliness of the fuel and the chemical structure of the fuel. And we'll talk a little bit more about that in this presentation, and also with our partners, Neste, who are on this call today. They're going to go into a lot more of the chemistry. So ultimately, HVO, although it's vegetable origin, it's not a biodiesel. And I know biodiesel, that word can turn people's face to horror. It's a very, very different product. Due to the magic of chemistry, we manufacture or the product is manufactured in a completely different way. And I'm hoping you can see the two bottles I've got in my hand here. This one is biodiesel. This one is HVO. Now, these two products are exactly the same age and have been laid up and maturing here in my office for the last 6 months in a dark box. And as you can see, biodiesel, famed biodiesel, starts to degrade over a period of time, whereas the HVO has stayed pure and crystal clean. Again, showing that, the main point of that really is to show that they are completely different products. And of course, HVO will give you benefits versus biodiesel and versus mineral, and some of those, whoops, got a bit overexcited there. So benefit versus biodiesels, it's a consistent product. HVO, the amount of chemical processing that goes into producing HVO essentially means that feedstock variations can be taken out of a variation in the final product, whereas biodiesel, it's not particularly heavily processed. So the feedstock can really change the properties of the final product. It's a true diesel fuel, and again, my partners will be telling you more about the structure, but in essence, HVO is a hydrocarbon. What the manufacturers of the fuel do within a chemical reactor over a period of a day or so is essentially what the Earth's crust does over a period of 200 million years. So in effect, this is why we can call it a drop-in fuel. What the engine sees effectively is what it's been designed to see, is a hydrocarbon. No storage concerns. Again, you'll have all heard of the horror of diesel bug. Essentially, that's caused by biodiesel being mixed with standard mineral diesel. There is no biodiesel in HVO. HVO will and can sit for a 10-year shelf life. It separates water very, very well, and for all the reasons that bugs love biodiesel, they don't love HVO. So storage is far simpler. There's no heating required during storage. The pour point or the cold filter plug-in point of HVO can be as low as minus 32 degrees. Therefore, you don't need to heat storage, whereas sometimes with biodiesel you do. And again, cold filter plugging, it won't block filters during winter time. And it can be mixed in all proportions with mineral diesel. In terms of benefits versus mineral diesel, it's a non-blend, it's consistent. So what we get out of the pipe, we know we're going to get out of the pipe. Mineral diesel is a blend. If I was to fill a tank of fuel here at home in Dorset, go up north and refill my tank, in essence, I would be getting a very different fuel. Okay, it meets the specification, but that specification is pretty wide. Whereas HVO, you know what you're going to get, and it's consistent across the country or across storage locations. There are no aromatics within HVO. This improves the burn efficiency and is in part one of the reasons why you don't get the particulate smoke that you get from standard diesel. And importantly, HVO, because of the lack of aromatics, doesn't have health hazards associated with it as per standard fuel, i.e. carcinogenic warnings, and also the toxic to aquatic and the environment warnings that you do get with mineral diesel. Hence the health and environmental risk. It looks like I'm getting ahead of myself. We have seen fuel savings, and we do see fuel savings certainly within NRMM. Definitely we get particulate reductions and of course NOx reductions as well. So why do we say renewable and sustainable and low GHG? This slide really is a distillation of that topic. We could write books on it, but in effect, renewability is all about short-term use and renew cycle. HVO is manufactured from waste-derived feedstocks, majority of which would be used cooking oil, which of course is produced from plant matter. So that renew cycle is effectively the growth cycle of a plant, 1 year growth cycle. Sustainability basically equals there's no damage to the environment during that renewable renew cycle. HVO is produced in a way that the crop is not taking away food production. It's also produced in a way that is not deforesting. On global deforestation, it can't be used. Crops that contribute to global deforestation cannot be used in HVO production that then can be placed onto the market according to the RTFO. Low GHG, effectively that means that any CO2 that's produced does not linger within the atmosphere and ultimately doesn't increase the concentration of CO2 within the atmosphere. And the little graph here is trying to kind of show you where we are. If we look at fossil-based CO2, the input of CO2 to go to make that fossil fuel is a 200 million year cycle, whereas the output of CO2, unfortunately, where we've got it wrong is 200 million years in, and we've burnt it all within the last 100 years. So it's completely out of balance. However, with a low GHG fuel such as HVO, we try and get the balance in place. So the speed of your sequestering your CO2 into the crop is at the same rate as the output of CO2. And that's the basis behind low GHG liquid fuels. So if we look at HVO, it's all very well me wittering on about sustainability, etc. But what checks and balances are in place in the market? So first of all, in order to even think about calling a fuel sustainable, it needs to meet the Renewable Energy Directive. And whilst we're no longer European here in the UK, RED is part of legislation, and that was transferred into UK legislation on the 31st of January this year. And that basically tells people what feedstocks, what types of product can be called renewable fuels. It sets out the LCA, the life cycle analysis that's required in order to put a value on the carbon intensity of the fuel. And it says to member states at that time in the EU, it says, right, here's the basis, now go away and put some legislation in place to make sure that you meet our directive. We have also a proof of sustainability, what we would call a POS. This is issued by an independent organisation, ISCC, and they effectively take the collection, transportation of raw material, the CO2 output of production, and then the CO2 output of transportation of finished product into storage, and then collate that data and provide a carbon intensity. The UK, we went away and we said, okay, RED 2's here, so let's put in our own legislation, the Road Transport Fuel Obligation, which essentially says in order for a fuel to go to the market, that's claiming to be sustainable, it must have a minimum GHG saving of 60% versus mineral fuel. It must be certified by an independent product organisation, and it must meet the requirements of RED. Each sale that we make here in the UK has to be independently verified by the Department of Transport, who are the gatekeepers and owners of the RTFO obligation. And finally, if all of the previous 4 considerations are met, then Crown Oil are issued with RTFC, road transport fuel certificates. And this essentially means that we can place the fuel on the market at a commercially viable level. Without RTFCs, Crown Oil wouldn't be able to sell a litre of fuel because there's no way that the price of that fuel would be commercially viable. I was asked as part of the presentation to talk about electrification. Now, there's been obviously a number of announcements recently about electrification in the market and how the UK are moving to electrification, partly and mostly, I think, because of their zero output in terms of tailpipe emission. But there are some areas where I think it's worth questioning some of that strategy. Certainly, IMechE, the Institute of Mechanical Engineers, have recently published a study which suggests that the overall life cycle analysis of an electric vehicle or electric hybrid isn't actually that attractive when you consider where the lithium for batteries is being produced, how it's being produced, all the transportation, and also the amount of CO2 that's going into producing the vehicles in a holistic sense. Now, if we look at diesel fuel, and certainly here where it stands now, it's pretty high up on the bad CO2 output scale. However, if you take a diesel engine or a diesel car and run that on HVO, for instance, you get down to these sorts of levels, which are far, far lower. And then you take a BEV, and according to the methodology used by IMechE, that actually a diesel car where there are, of course, savings in place and the logistics chain is well lubricated, a diesel engine fired on HVO actually provides a pretty good alternative to a BEV in terms of GHG CO2 overall emission. And part of that, of course, is where do we get the electricity from? Now, again, we've looked on the UK grid, and BEIS, the UK government's own estimations are that the UK grid won't be carbon neutral till about 2050. And that takes into account the fact that we're going to have to build more nuclear plant as well in order to get to those sorts of levels. And a real quick look at the UK's CO2 output of electricity, and this was taken last Friday afternoon. We were producing around about 341 grams of CO2 per kilowatt hour last Friday. Now, Crown HVO, the carbon intensity that's certified independently, works out at 32 grams per grams CO2 equivalent per kilowatt hour. So you can see it's around about 10 times lower than current grid. And indeed, current grid wouldn't get to Crown HVO or HVO's levels until around about 2041 or 2042. So it's worth thinking about, and it's certainly worth questioning where we're going and where the CO2 reduction is actually the driving force behind electric vehicles. I get where they're coming from in terms of emission, noxious gas emission. I can understand that within town centres, etc. However, linking that as well to CO2 is perhaps a step too far at this point in time. So just looking a little bit more in depth on that then, and the tailpipes emissions, in terms of HVO, we would expect to see around about, and these are average or mean emission outputs. We would expect to see around about 30% reduction in particulate matter, around about 30% reduction in total hydrocarbons, and this is around the greater efficiency of burn of HVO within the cylinder. Again, plus or minus 25% reduction in carbon monoxide linked to efficiency of burn, and 10% reduction in nitrous oxides as well. And we have test data that we've generated ourselves, and of course our partners have as well. And these, a little example of these here, this is a piece of NRMM, this is a generator, which of course in certain instances we generate peak electricity based on diesel here in the UK. And we saw CO2 reduction of 4.1, although this says CO2, this is really around about fuel consumption. So a 4.1% reduction in fuel consumption. Total hydrocarbons, very much cut. NOx reduction of 7% there. On road, this has been generated by our partners, and this is a wide-ranging study that was conducted for vehicles on road, buses, trucks, cars, etc., which shows the levels of reductions in all these nasties that you can gain with HVO. And I think there's two distinct things here. There's that tailpipe noxious benefit, and of course the GHG benefit. And you know, to put it into figures, 1,000 litres of diesel would produce around about 3.6 tonnes of GHG CO2, whereas HVO would produce around 195 kilograms of GHG. So you can see how quickly you can start reducing that CO2 burden simply by changing your mineral diesel for HVO fuel. Now, HVO, it's new to the UK market, relatively new, shall I say, but it's not as new as people might think. The fuel is old enough, shall we say, to have been included in international fuel standards. It's an EN 15940 paraffinic fuel. It also meets ASTM D975, which is obviously the US standard for diesel. Sadly, or the difficulty is that it doesn't meet EN 590. However, it meets that spec in all aspects apart from density. And slightly annoyingly, the density of EN 590 is higher than HVO because of the nasties, because of the aromatics that mineral diesel have. So sadly, we're not able to meet the ubiquitous spec because our fuel is cleaner and less toxic to the environment and indeed people. There's a large number of direct OEM approvals. There's a smattering here on the right-hand side of this slide. Others can use the fuel as an ASTM D975 product. But of course, it's always worth checking with your OEM before you go ahead and do that, because warranties are something that can be complicated. And we wouldn't ever advocate somebody using a fuel and potentially losing the warranty on their vehicle. It's been available in continental Europe for more than 10 years, and I know Neste are going to talk a little bit more about that later on. And again, what they're going to talk about is it's available on pump in areas such as Scandinavia and Benelux to the general public, which should give you a feeling that the fuel is completely fine for use, if allowed to go on to general use. Just don't take my word for it. We've conducted many trials. This one is a nice little example. So we did a trial with a partner of ours, Land and Water, who are a construction company that, as their name suggests, they operate on the margins. They do things like canal dredging and reclamation work in wet environments, so environmentally sensitive environments. We burnt the fuel in a 28-ton excavator. It was a Tier 4, a modern Tier 4 engine. We burnt 6,000 litres of HVO and compared that to burning 6,000 litres of mineral fuel. It was a tough old time. Last winter was pretty wet. The digger itself was working hard to move the muck that it needed to move, and indeed move itself. And it was operating roughly 15 hours a day, 7 days a week. So what did we see? The work rates were comparable between HVO and diesel. The excavator moved and had to do what it had to do, regardless of what fuel it was burning. There were no issues. It didn't break down, luckily for us. The operator reported no issues, and this was seen for us, certainly, and Land and Water, as the acid test. They were pretty clear that if the operator felt that the machine was lacking power, or it wasn't moving as much muck as it should do, they'd certainly pipe up and tell us. And we also got a nice little bonus of a 10% reduction in fuel consumption. But if you look at the CO2 and look at the environmental impact of the diesel fuel, the HVO, sorry, versus diesel, we saw that diesel, that 6,000 litres, would have produced roughly 19 tonnes of GHG, carbon dioxide, and around about 210 kilos of NOx. Whereas with HVO, we only produced 1,200 kilos of CO2. So slash the amount of CO2 that was produced, GHG CO2 that was produced, and of course reduced NOx by around about roughly 50 kilos. So not an insignificant reduction either. So why wouldn't you use Crown HVO? It's, you know, operability is under no question. It has legislative backup, that 5-stage backup that I showed on a previous slide. Its performance is accepted and rubber stamped by a number of OEMs, and that list is growing. It's environmentally beneficial. Again, the legislation tells us that it's environmentally beneficial. It offers a fast and simple step towards net zero. Net zero, of course, doesn't mean that you cannot produce CO2. It just means that it has to be sustainable CO2 that doesn't increase the concentration of that gas in the atmosphere. And importantly, it does so with no capex. You don't have to change your equipment. You don't have to change your infrastructure in order to move to HVO fuel. The one downside, of course, is cost. HVO is not produced in the same quantities as mineral fuel. It does cost more. Ultimately, we've had 100 years of refining mineral fuel to drive the costs down. We haven't had that, and we don't have the savings, volume savings that you get from mineral fuel. But however, you know, the cost of HVO isn't massively different to mineral diesel. So in effect, what you're doing is you're moving a capex requirement to go green to an OPEX requirement. In terms of availability, HVO capacity is growing globally. very, very quickly. Capacity's grown by at least 50% in the last 3 years, and there's more and more announcements coming on. A number of large global refineries are shifting towards HVO or HVO co-produced mineral diesel fuels. So that capacity is coming on, and certainly capacity at the moment is meeting demand. The majority of production is in Europe. North America and Asia are also close behind. Crown Oil, we've got product, we've got both red and white positioned across in the UK. We've got it in 9 tanks now around the UK, so we can do both of those fuels within you know, a vast majority same day or within 3 days. We can also do smaller drops, hard to reach locations. Of course, that may take a little bit longer, but we can still do it. And we can do packs and 1,000 litre 205 drums, etc.
Simon, can I remind you of time?
Yes, I'm just finishing up.
Thank you.
So in summary, HVO, it's bio-derived, but biodiesel free. It avoids the stability and operational issues of high blend biofuels. Production process leaves a shelf life of 10 years, reduces net GHG CO2 by around about 90%, reduces particulate and NOx emissions, zero capex cost to change. You can contribute to net zero targets very, very quickly. High flash point, so it is improving safety, handling and storage. Low CFPPs. It is also biodegradable, so it avoids environmental damage if released into the ecosystem. We're seeing improved fuel consumption, certainly within an RMM machinery. And Crown Oil, we're able to supply nationally in bulk or as pack stock. Thank you very much. If anyone would like to contact me at any point, then my details there, and I'm open now to questions.
Simon, well, thank you very much for your interesting presentation. This was quite revealing in many ways.
Good, I'm glad.
So Alex, do you want to put out have we had any questions for Simon?
We have, yes. There's been quite a few coming in, so thanks to everybody for those. Simon, do you consider HVO fuel to be a product that will be exclusively a commercial fuel for use in plants, heavy goods, generators, or do you see it potentially as being a fuel that will replace mainstream diesel on the petrol station forecourts?
Well, it's certainly on the petrol station forecourts on the continent. Of course, one of the constraints is capacity. However, as I've already said, we do see HVO growing quickly. Whether that capacity can meet forecourt requirements is a question. I don't know is that answer, but there's no reason why technically it can't be burnt and can't be used on forecourt.
Okay. Can it be used as a replacement for marine bunker sea fuels?
Yes.
It can. Okay. One other question was, you mentioned there about if you spill the product, it's biodegradable. Somebody asked, you know, would it have similar issues that cooking oils and fats do in terms of build-up of fatbergs and those kind of plugs? I'm assuming not, because it's a refinery.
No, not at all. Yeah, it's not the same chemical structure in any way, shape or form. So no, it doesn't freeze in the same way as that type of product.
Okay. Another question is there any effects in the trials and testing you've done of HVO of elastomers, seals, gaskets in the vehicles, in the engines, in the storage and transfer supply chain?
No, we haven't seen anything, and that's again down to its chemical structure. You can, you know, what you get with seals with mineral diesel, you can read across onto HVO. Yes, there's issues around seal materials with biodiesel, but they are very different. Biodiesel is very polar. It's a very, very good solvent, and it extracts the plasticizers from rubber, whereas HVO doesn't do that chemically. It doesn't do it. It's a bad solvent, so not a problem.
Okay. Thank you. That was all the questions that came in.
Okay.
Very much.
No problem.
These buttons and clicking going on here. So anyway, Simon, thank you once again for your presentation. And the next presentation is a joint presentation by Magdalena Strijffert and Quentin Gauthuer of Neste, Sweden. I think Magdalena will set the lead on this one. She is Head of Public Affairs at Neste, dealing with regulations and policy. Previously, she was the Secretary General of the Swedish Fair Trade Association, and she's also a former MP of the Swedish Parliament. So, Magdalena, welcome to the England, to the UK.
Thank you. Very happy to be here.
Yours.
Thank you. Can I share my screen then?
Yes,
Maybe?
we have to. I'll have to set that up for you, I think. And
yeah, I think. Let's see. Do you see anything?
That's working.
Yes, that's always the question for digital meetings. Thank you for having us. It's really interesting to listen to you as also contribute also as well when it comes to HVO. And I think the name of this session was challenges for the Swedish market. I would say more opportunities maybe than challenges, but we'll see after this presentation.
Can everybody see Magdalena's presentation?
Yes.
Yeah. Yes. Yeah.
Good. Just short about Neste as a company. We were founded 1948 with the purpose to secure Finland's oil supply. We have made this transition. It's not my phone, I'm just saying. We made a transition from being a traditional oil company to become one of the world's largest producer of biofuel. And it started already in 1996. Where we developed our technology to produce 100% renewable diesel, HVO. Last year, for example, our renewable products help our customers to reduce greenhouse emissions by 9.6 million tons. And we also have quite bold climate targets. One of them is to help our customers to reduce the green gas emissions by 20 million tons per year by 2030. And the other one is that our production should be carbon neutral by 2035. So with that said, I think, I jump into, if you say so, Sweden and the Swedish market. And I start with a very humble chart here from EU Commission and on how the member states are achieving the target of reducing GHG emissions by 6% compared to 2010. And as you can see here, Sweden is far ahead other member states when it comes to the reduction of GHG emissions, while other member states are still struggling. The target is for 2020. Sweden is come very far. And one of the reasons we have achieved that is because we have very ambitious climate targets nationally. We have one of them is that we want to reduce the emissions in the transport sector by 70% by 2030. And here is also how the government wants to achieve that target. 2018, we already reduced the emissions by 18%. Sorry, this is in Swedish, but I will explain. And then they see that using more biofuels, because a lot of those 18% was actually due to the fact that we have been using biofuels for a long time in Sweden. and we see that it will be the most important tool also for the target 2030. So by using more biofuels, we reduce the GHG emission by 32%. Using more electrification, using more electrified vehicles, that will reduce the emissions by 15%, to have a more efficient transport with public transportations and more people not using their cars, that we could reduce the emissions by 5%, and then we have still 30% left that we will reduce to 2045. But here you can see, as the Swedish government sees biofuels as a very important tool to reduce the emissions. And the tool for that is to have, I think it's the world's most ambitious reduction quota biomandates when it comes to road transportation. Today, the fuel retailer needs to blend in biofuels both for gasoline and for diesel. Today, the level for gasoline, the biofuel for gasoline is around 4%. For diesel, the diesel pool is 21% is GHG based. Here on the left side, you see also the levels for next year and to 2030. Very high levels for the blend-in for diesel, 26% next year, and to 2030 it will be 67% blend-in GHG targets. And then the Swedish Energy Agency actually also estimated what kind of volumes is needed to fulfill the reduction quota in Sweden. And here you can see that the green bar here is HVO, so we'll need a lot of volumes of HVO, and for 2030 they say it's around 4 million cubic meter. So that's the sort of HVO that you blend in. Simon, as you heard from Crown Oil, talked about HVO 100. You know, that's sort of fossil-free product, and with where you can with the GHG emission up to 90% compared to fossil fuel. And the beauty of the Swedish model, I will say, is that, you know, when you blend in biofuels in diesel and gasoline, you know, the tax system, then you have to sort of, it's the ordinary taxes, CO2 and energy taxes, that is required. But when it comes to HVO and other clean biofuels, there is actually a tax exemption, and it has been for 15 years, that makes it possible for the Swedish government to actually to promote HVO 100, and it makes it easier for companies, public transportation, for consumers, for organizations, and others to be forerunners and to fill the car with HVO 100. And for example, the public transportation, and 90% of the public buses actually runs on clean biofuels and HVO 100, for example. So that makes Simon ended actually talking about the cost. So the difference between sort of ordinary diesel and HVO 100, for example, is not that big, and that makes it, of course, easier for others to fill their for the buses and the vehicles with HVO 100. So this sort of paved the way for the big market for HVO in Sweden, and so that's sort of a great opportunity. With that said, now I will, because I'm not good at technical issues as I work with public affairs, so I will give the floor to my colleague Quentin.
Hi, can everybody hear me?
Yes.
Yeah. Okay. So yes, indeed, as Magdalena said, Sweden basically have made the bet to go for HVO, so it allowed us for the last years to sell huge volume there. And I would say that UK can then take the opportunity to look at those neighbors countries and see what's going on there. So just to present myself, I'm technical account manager, Quentin Gauthuer. I'm actually based in Helsinki, headquarter of Neste. But as you can hear from my accent, I'm more from across the channel from you guys. But yeah, I've been working with Simon. So I know very well Simon from Crown Oil, and basically supporting our partner with technical expertise. But anyway, here the question was, were there any technical issues in Sweden? And well, it's difficult to find issues because we don't have actual issues with the product. And Sweden is not the only example. We don't have issues in Sweden. We don't have issues in Finland. We don't have issues in Netherlands, the US, all those markets where we have been delivering HVO 100 for more than 5 years, 7 years. So this is why this product is more and more requested, and this is why more and more partners want to work with this product. But there is explanation on why there is no technical issues, and basically in few slides I will explain why there is no technical issues, and it's a bit something that Simon has evoked earlier, but let's go more into the chemical background of why. So Magdalena, next slide please. So here it's on purpose very technical and very chemistry, but basically here you have all the chemical molecules that you can find in a fossil diesel. So you have 4 types of molecules: paraffins, normal paraffins and isoparaffins, olefins and aromatics. And also what you can see is that you have a wide range of size, from the smaller one containing 9 atoms of carbons to the bigger one, 23 atoms of carbon. These are what you can find in diesel. Basically what comes from crude oil that you have distillate, and then the olefins appear during the process. But basically that's normal molecules that you can find in hydrocarbons, and that's why an engine is prepared to see and to burn. Now, if we check what is on HVO in the next slide, you can see that actually what HVO is basically a short selection of those molecules. So we have first a very small range from 15 atoms of carbons to 18, but we also have only paraffins. So basically that's why it's a better fuel in combustion, and why it has all those good benefit with the engines, but it's also why it's compatible, because actually the molecule in Neste, well, Neste is, just for explanation, is the brand name that Neste is using in Sweden, Netherlands, Baltic countries, Finland, and the US. It's not something that you will find as branded as such in the UK. In the UK, you can find the Crown HVO, for example. But basically, you have only molecules that are also existing in fossil diesel, and that's why there is compatibility and no technical issues. However, as you can see, there is no aromatics, and just to answer to one of the questions that was asked by the crowd to Simon about the elastomers, rubber, and leakage, there is a theory around the fact that aromatic-free fuel can create impact on rubbers. Well, if you do the experimentation in the lab, you can see some impact, but that's something that we have not seen in the markets. And that's to say that there is always a difference between what you can prove in the lab and what actually the field test is reflecting. And what we see is that if a user, a fleet manager or a personal user, is doing the good servicing with their car as requested by the constructor, you will have no impact on your vehicle. So this is something that is said, and that you can see in some literature, but in the field we have never seen it. Now, the other thing toward which we can compare the HVO is the biodiesel fame. Obviously, they are both biodiesel component. So in the next slide, I just want to clearly differentiate those things on the chemical side. So you go from the same feedstock, the triglycerides, the fats, the oils, and then to produce the fame, you do this esterification, and you get those methyl ester components. What we do is hydrotreatment, and you get those hydrocarbon components. The big difference is that you can see that those red atoms, which are the oxygen atoms, they are not there anymore in our product. That is the reason why our product is more stable. Our product is non-polar, so it will not clean out the tanks and fill your filter with dust and rust that the flame will do, because the flame will, because of this polar effect, the flame will gather the component in the bottom of the tank and fill the filter. And basically the lack of oxygen is the reason why flame and HVO are so different components. I think that's pretty much all I wanted to present today. But obviously you can contact me anytime after this conference if you have any question on the technical background, the production processes and all. Thank you for your attention. And if you have any question, please.
Thanks, guys. Very, very interesting. There has been a couple of questions. Has the UK government been in contact with Neste at all, or the Swedish government? Maybe Magdalena, who used to be a member of parliament in Sweden, maybe you know. Is there any discussion between the UK government and Scandinavian government regarding HVO and the work that the Swedish government have done to reduce greenhouse gases by using biofuels such as HVO?
I think that's, yeah, you hear me, yeah. Yeah, I
Yes.
think, yes, good. Yeah, I think it was, there's been some discussions, yes. I know that Sweden really was very sad, or many reasons, when UK left the EU, though, because we work quite good together in those kind of issues as well. So there's been some discussions, I know. And especially, I think, around also the tax exemptions as well. That is an interesting, tool to use as well. But not more than that. I don't know. It just, at least during my time in Parliament recently, sorry to say, don't think they've been that much in contact with Neste yet. But hopefully they will soon.
Just to comment on this, we have been in contact with our public affairs have been in contact as well with the UK. For example, at the time where the RTFO was questioning the HVO as a bio component for diesel. So we have been in contact with them, but it's always difficult for a company like Neste, which is a Finnish-based company without any entity in UK, to have time, and to receive some time from the Ministry for Transport or Ministry for Energy to discuss. And in Sweden, it's be easier because we have there a company already owning some parts.
Okay. There's a question here which probably might be something for a combination of Simon and Magdalena and Quentin. But do you have an example cost of HVO? If I was going to buy a litre of HVO versus a litre of regular diesel in the UK, what is the actual cost difference? I know it's more expensive, Simon mentioned, but is there a kind of price that somebody's asked for an exact idea of what that price difference is?
Simon, if you can take this one, I guess.
Is Simon there?
Yeah, I'm here. Yeah, sorry.
Okay.
Hello. Yeah, you can hear me.
We hear you,
yeah. It's difficult to say and put a real finger on there. It depends on volumes, blah blah blah. But you're looking 10 to 15p a litre difference at this point in time. One of the positive points about HVO is that the cost of HVO is relatively stable. Obviously, standard diesel goes up minute by minute, hour by hour, day by day, or down, whichever way it changes. HVO is relatively stable, and therefore that allows us to offer longer term pricing for the fuel. But you have to, obviously, as I sort of mentioned in my slides, you have to look at that OPEX difference against the zero CapEx.
Yeah, so the comparison is not so much between diesel and HVO, but more between how much sustainable cost, how much being sustainable cost.
Exactly. There are matrices, I understand, within the UK government now that are waiting to be published, which sort of quantify the cost of CO2. And once they are published and potentially once they are being taxed, then prices of HVO, I think, will look a lot more attractive than they are today.
Okay, thank you. And another question here was, if we moved towards HVO in a much bigger way across the transport sector, would it become a fuel that would use crops that we currently use for feeding ourselves and eating, or would it lead to deforestation because you're using biomaterial to create a fuel rather than for, you know, for us to feed ourselves or for, you know, forests?
No, you don't have to be Magdalena here. We actually, it's waste and residues as we use for raw materials for our HVO 100. It's over 80%, and we will have for 2025 100% waste and residues as raw materials for our HVO.
If there was a real uptake in HVO, would there be enough waste oil
Yes.
things to create?
Yeah, we actually developed our technology so we can use more low quality of waste and residue streams from food industry, fish industry, and so on. And we have, you know, we see that there is a potential of 35 million tons waste and residue streams by 2030. So we see there will be, you know, enough. And then we also develop other technologies as well to use residues from forest or agriculture. That's a different technology, but still there will be also other feedstocks to use that based on waste and residues. So yeah, I know there is a discussion also in Sweden and everywhere, will there be enough? But we see that you know, it's not, you know, fixed. So we will of course develop and innovate and see new technologies and new more low quality of waste and residue streams. So yes, we don't see that as it would be a challenge, but not, you know, not as big as we other think it would be.
Okay, thank you. That was all of the questions.
Great.
Good.
I have a question, if that's possible.
Okay.
I've no idea how to submit it to you.
Who's
otherwise
the
I would have
question
done
from?
so.
Who's asking the question?
Ian David Parker.
Go ahead.
The obvious question that nobody seems to be asking is the entire car market of various countries are all going to go out of business here because they're not going to be able to make diesel engines. All the industry, all the supporting businesses, everything else, and we're saying that there's a perfectly acceptable substitute fuel on the market in Europe, and that the UK government isn't looking at this seriously. That beggars belief. I can't believe it. Surely that can't be right.
Unfortunately, my experience, and this is my opinion and my experience, is that the UK government have listened intently to quangos who are pushing the EV agenda. And whilst there's a massive place for EV, what we've got to understand and what everybody's got to realize is that there's no one solution that fits all. At the minute, we've got a one solution that fits all where we are burning fossil fuels, liquid fuels, petrol or diesel. The transition to a low carbon economy will mean that ultimately things will get more complicated, but you will have a suite of different technologies. Yes, EV within town centres, cities, blah, blah, makes good sense. You know, London, part of the problem with London is you've got 20-year-old taxis chuffing around at 20 miles an hour with old engines that are throwing diesel out. Yeah, if we can move those to EV, that's a no-brainer and it makes sense. But sadly, the UK government has lost its focus and lost its mojo for liquid fuels and are potentially heading towards a little bit of a disaster's too strong a word, but heading towards a brick wall with EV. Because let's take it, you know, we've got to put loads of EV charging points in. How are we going to do that? Well, we're going to do that by burning diesel in diggers. We've got to put fast chargers in. How do you get fast chargers? Well, if you want to put 20 Tesla fast chargers in a roadside motorway services, you're going to have to build a power station to run them. So there's lots of different problems associated with it, and as you quite rightly say, Ian, we've got a drop in fuel that we can start getting into businesses now, but the UK government sadly aren't listening.
Simon, I think you've hit one of the nails definitely on the head there. The UK government hasn't looked at the fact if we all remove petrol and diesel vehicles off the road, where's the power generation going to come from to power all these vehicles? We're getting close to capacity at the moment.
Absolutely. One of the reasons why last Friday the UK energy market was running at 300 grams per kilowatt hour was probably because it was peak time and we were spinning up diesel generators. Yeah, it doesn't add up. It doesn't add up.
I'll just add to that. For those of you who attended the APEA technical conference in Milton Keynes last year, there was a very sober presentation by my colleague Stefan Kunter, what was being done with synthetic fuels, alternative forms of energy for the automotive market, and particularly in countries such as Germany. Unfortunately, as you say, the UK seems to have gone a little bit off track, but I think for all of us who are in this industry, it's important that we can try and perhaps influence the policymakers in order that there is more flexibility in the system. We see what happens when dates draw close to deadlines. And so I'm sure there will be a bit of push and shove all around, but it was a very interesting presentation, I think, for all of us to listen to, for the presenters of HVO. Very exciting product by the sounds of it. So once again, thank you very much to Magdalena from Sweden and Quentin from Helsinki. Yeah. On that basis, Alex, shall we move to the next presentation?
Should, yes.
Which is from, again, it's another joint presentation by Andrew Olive of Pumptronics and Bert Fowler of Vectec. Andrew is the commercial director for High Tech and has responsibility for Pumptronics, which is a fueling dispenser used in the commercial and retail sector. Andrew's been in the business for many years and through his drive, initiative and ambition achieved the Queen's Award for Enterprise some years ago. This is quite a coveted award to be given. So Andrew, if you can hear us in the ether, the floor is yours.
Thank you very much, Anton. Thank you for the introduction. As Anton said, I'm the commercial director of High Tech. Many of you will know me from the industry within the Pumptronics. And as Anton says, I've had quite a few years within the industry. The Pumptronics equipment is predominantly supplied into the commercial sector. So we're involved in supplying equipment to fuel bunkering sites, distribution centres, haulage yards, but that's all predominantly commercial vehicles, so it's non-public use and it's generally diesel-based fuels. We do also get involved in industrial and automotive sectors, and here we have a mixture of petroleum, diesel and aviation fuels. We've all sort of had discussions about the phasing out of fossil fuels and where we're going to go with diesel and petrol cars. And if we look at where we need to be at 2035, we are looking at the capability to have plug-in hybrids or full hybrids. That's still to be determined, and that will be defined through future consultation. What it does mean, I think, from a transition point of view, there are commercial manufacturers out there introducing hybrid models, and these tend to use range extenders. So here the petrol engine is being used to recharge batteries or act as a backup to drive the wheels. Generally, hybrid vans can have a higher payload, and that's because they have smaller batteries and a longer effective range. If we just look at petrol contains volatile organic compounds, and it's these hydrocarbons in petrol that evaporates inside the fuel tank and into the airspace above the liquid fuel. And it's these vapors that create a potential explosion risk and a risk to public health and contribute to greenhouse gases. And it's during the refueling process that these vapors are forced out from the fuel tank by the incoming fuel unless it's controlled. There is an EU directive that sets out the requirements to capture these petrol vapors, and that works on the principles of stage 1 and stage 2 vapor recovery. Stage 1 relates to the delivery of fuel from the road tanker to the petrol storage tank, and stage 2 relates to dispensing the fuel from the fuel pump to the vehicle tank. And this presentation will be focusing on the stage 2 vapor recovery side. Within the directive, it sets out the requirements that stage 2 vapor recovery should be fitted to new sites, those undergoing major refurbishments and selling more than 500,000 litres of petrol per annum. It also sets out the capture efficiencies need to be greater or equal to 85%. That means for every 100 litres of petrol we are dispensing, we are looking to capture 85 litres equivalent of vapour. So how do we achieve? How is that achieved? If we look at a normal fuel dispenser, we are taking fuel from the storage tank. And the fuel pump is pushing the fuel through to an adapter here, where we then have a coaxial hose. The outside of the coaxial hose is where the fuel is dispensed down through to the nozzle and into the tank. We've also then got the addition now of a vacuum pump inside the fuel dispenser. That vacuum pump is generating a vacuum. So as you are dispensing fuel into the tank, the vacuum created is drawing the vapor from above the fuel, drawing it through the inside of the coaxial cable, coaxial hose, and through back into the underground tank. In order to meet the 85% efficiencies, there has to be a way of controlling that and calibrating that. So there tends to be two ways of doing that. We can either use a proportional valve on the nozzle, and on this valve we can then calibrate. During calibration, we can open or close that valve. There is the option to have a proportional valve inside the actual fuel dispenser itself, which is then linked to the electronics. Generally, though, within the commercial sector, we would tend to use option 1 here, where we're using a proportional valve within the nozzle. In order to ensure that we are compliant with the 85% plus, we need to calibrate it. And in order to do that, there's 3 main components here. There's an adapter that goes across the end of the nozzle. We have a gas meter here, which has got an electronic output to a handheld terminal. So in order to calibrate that, we are dispensing fuel through the nozzle, through the adapter. the vacuum pump is drawing air in through the gas meter, and we've then got an output coming to our handheld terminal. So by using that setup, if we're not meeting the 85% requirement, we can go into the nozzle, adjust the proportional valve, and that will then achieve the correct tolerance. It's also important there's a appropriate maintenance schedule to monitor the stage 2 vapour recovery. As part of our production, we can calibrate the pump itself. When it's in service, there is a requirement that is tested at least once a year, in order to make sure that the vapour and petrol ratio is within the tolerance of the 85% plus. And you would do that on site using a similar setup with the gas meter and the handheld controller. We can also look at routine service testing on the side by using a little quick tester, which is like a little whistle. This unit here is put across the end of the nozzle on the stage 2 spout. As the vacuum pump is drawing vapour through, the movement of air is giving you a sound or a whistle. So that then gives you a yes or no function within the VR system. So if there's no sound, that means your VR system is defective. That just confirms that the vapour recovery system is working, but it doesn't confirm that you're meeting the 85% plus. So it's probably useful to understand from a zoning point of view what that really means. We have here, and these are examples from the APEA Blue Book. So here we can see the zone has been defined around the fuel dispenser, and we can see the various zone 1 and zone 2s around the pumping unit. If we look at the actual nozzle without stage 2 vapour recovery, we can see we have a large zone 0 and a smaller zone 1 based around the fuel nozzle. If we simplify that and look at it, what that means is potentially, and depending on the length of your hose, as you're moving your nozzle in and out away from the dispenser, we have a potential zone 1 hazardous area here. If we look at what happens when we implement stage 2 vapour recovery, we can see straight away the zone 0 has been reduced, and we have an increase in zone 2, so that's a less hazardous area, which then go into a simplified drawing here. We now have a zone 2 area coming away from the pump and to the point of dispensing. So we've been able to control and reduce that hazard. It's also probably worth just sort of touching on the diesel zones. There's been lots of discussion over recent years on diesel zones and the extent of diesel zones. That is defined now in the latest edition of the Blue Book, and that's based on really the high volume HGV sites on forecourts. So again, with diesel, we can see diesel has got some specified zones around here, so it's something that we need to be aware of. Again, if we turn around and simplify that and look at the diesel zones, when we looked at the petrol side, we would have had a zone coming up towards the top of the pump. So diesel does have a hazardous zone, but it's a lot less onerous than petrol, but it does need to be considered. So if we just look at a simple overview here, we can see here we are with the petrol zones. Diesel zone it does have a zone, but it's you can see the extent it is a lot less. So within the commercial sector, although there are pumps out there that are ATEX approved for diesel, it's important to understand that they are for diesel, and therefore you do need to undertake appropriate risk assessments. So a diesel ATEX product is not suitable for a petrol application. That needs to be determined by the manufacturer's zoning. And we can see here that petrol and diesel zones are significantly different, and we do need to be aware of that. If we look at the applications of stage 2 vapor recovery from a commercial point of view, predominantly that's been in the automotive sector, where we've had dispensers on the end of production lines, where we're looking to put a dose of fuel into the vehicle. So here we're using stage 2 vapor recovery to reduce the hazardous risk within what tends to be a confined space. More recently, where we have seen the introduction of some of the hybrid products, we're now seeing more petrol installations being added to the traditional commercial diesel sector. So at this point, I'm just going to pass you across to Bert Fowler over at Vectec, and he's going to talk about a case study he's recently done, and then at the end of it, we can answer any of your questions.
Hey, good afternoon, everybody. Can everyone see me or hear me? Preferably both.
We can, yes.
Yep.
You're
marvelous.
Okay.
Excellent. So, quick introductions then. My name's Bert Fowler. I'm the head of projects at Vectec. My company was started in 1994 by my father, Simon, with the goal of raising environmental and safety standards in the commercial refueling sector. I'm afraid I wasn't around in the early 1980s when Simon first started in the business, but the standards of commercial forecourts in those days were pretty poor, as I'm sure a lot of you who have been around a bit longer would be aware of. So we specialize in design, supply, installation and maintenance of fueling facilities. We work with all the major UK manufacturers in terms of tank fabricators, pump manufacturers, fuel management providers, etc. And more recently, certainly over the last 5 years of my 6 coming up 7 in the industry, we've done a lot more with petrol on the commercial side. So let's skip on and talk about the client in this case study, which it was Ocado Group. So quick bit of background. I'm sure you all know of Ocado, the world's largest dedicated online supermarket. They've got about 250,000 active customers and a 15% share of the UK online grocery market, according to their website. You might have come across the news of the fire at their big central fulfillment centre in Andover in February of last year. This was a huge hub, 10% of their total capacity, and was processing about 30,000 orders a week. So it was imperative that this was rebuilt, and they took the opportunity to do some redesign. Part of that redesign was a plan that Ocado will eventually switch over from diesel vans to hybrid petrol vans. I believe this fleet is due to be going live properly within the next 2 to 3 years. So Andover, whilst it was being redeveloped, was a perfect test site to kick this off. So I've just touched on that point. The aim, obviously, reduce the carbon footprint whilst growing the fleet and move ahead of the curve with the 2030 ban on the horizon. So that's a bit about the client. So early stage design, where do we get involved? So we were approached back in September of last year by MBA for a bit of advice on petrol storage, the pros and cons of above and below ground. The decision was to go below ground. It's a big old site, but a lot of vehicles around, a lot of activity, and they wanted to maximize the space available. With that in mind, they did have a large above ground diesel storage facility. That was decided that would go, and we would bolt on a large diesel compartment to the below ground tank that was being supplied. So 30,000 litres of petrol going below ground raised the question of, do we need to seriously consider stage 1B and stage 2 vapour recovery? Moving into the layout, hopefully you can all see this drawing that's popped up. So I'm not going to go into war and peace on this one, but you see the key up here indicating the diesel and petrol suction lines across the 3 fuel islands. Your smaller tank here is your petrol one with a couple of chambers, and your larger diesel tank is here. So vent and offset fills feeding back to a point here, a combined vent and offset fill point. You'll see this little red dots indicating the stage 1B vapor recovery coupling, which the petrol tanker connects to collect the petrol vapor as he's filling the petrol tank. You'll note that space is a little tight on island 1 here. It did require quite a bit of jiggling around to meet the hazardous zones, although having stage 2 vapor recovery, as Andrew alluded to a moment ago, it does reduce the radii of the hazardous zoning area, which made the design process a little easier. The stage 2 vapor recovery, you'll see indicated in these bright blue lines here, where the proportional nozzles are taking the vapor away from the fueling transaction and back down into the petrol tank, which again will be collected through the stage 1B process. So the question sort of linking into this Andrew's presentation is, why stage 2 vapor recovery in the commercial sector? I think that the primary reason that I hear from customers and people who are considering this is environmental compliance. So ultimately, it's the law, it's the advice, it's the legislation. You've got to comply to it. Permits for vapor recovery are issued through the local authorities department for pollution in the instances where I've worked on them, and it's coming from DEFRA guidelines. There's a long process note there from December 2013, which is the most recent I could find on the subject. Any new service station, as Andrew said, which is either being built or being seriously refurbished, must have stage 2 vapor recovery if their throughput is 500,000 litres or more per annum. Alongside that is the driver is safety. So obviously, every time you fill a petrol tank, or you're taking petrol out of a petrol tank through the pump, you're going to experience hazardous but explosive vapors coming out of a vent pipe in and around an offset fill point or through the pump and the pump nozzle itself. So stage 2 vapor recovery massively reduces the amount of vapor getting into the atmosphere. And, you know, God forbid somebody's filling a tank, filling a car with a fag on, or is operating some bit of electrical equipment that isn't ATEX rated, and you get a spark. It's a hazard that everyone could do without. In the case of Ocado, obviously, at present, the hybrid fleet is very, very small. So they're nowhere near 500,000 litres. But the decision was made whilst everything was dug up and everything was being redone, fit it immediately on the basis that they considered they comfortably crossed the 500,000 litre threshold, and the whole hybrid fleet was live, rather than try and do a costly and disruptive retrofit further down the line. So as part of the project, we had to deal with petroleum licensing. So I'll touch on this process quickly. Obviously, a lot of petroleum officers on the call today. I recognised a couple of names. So licenses are granted normally by a local authority's trading standards department or the local fire and rescue service. That's more so the case in my experience in the inner cities. Petroleum officers are usually present at the point of delivery of the fuel tank as it goes into the ground. Also want to be present to witness the pressure testing, and finally to oversee the commissioning process. COVID made that slightly challenging this time around with this project, so that was achieved really through a lot of photos and documents being emailed across. On top of this, the submission for a license must include as-built drawings of the pipework in the ground, the drainage plan, the tank, and technical specifications of every bit of equipment that's relevant or that's part of that refueling facility, as well as a full-blown DESIR safe operation method statement and risk assessment to ensure that everybody knows how to use the facility safely and properly. Vectec's role in this project, I think I've talked about, so let's move on. So the equipment we put in, I'm not going to hang on too long about this, but it was a double skin cylindrical fuel tank, a process that I insist upon on any below ground install that I do is that it arrives pre-strapped to a mounting cradle, on a steel mesh base frame. The idea behind this is that there's no danger that straps can be cast into the wrong location in the excavation. Everything's secure, and once that base frame is concreted in, that provides you a reinforced concrete base. There's also no requirement for any operatives, engineers to be going down the excavation, and obviously big HSE concerns with doing that, particularly in the construction industry. There's a class 1 leak detection system on there, as per the blue book, to monitor the interstitial space between the tank skins. Suction and offset fill lines are all secondary containment plastic Durapipe. Vent and stage 2 vapor recovery lines only require primary containment because they will intermittently contain vapor when the tank is being filled or when a fueling transaction is happening, but there's no actual petrol in those lines. And the pumps being used, Pumptronics C series with stage 2 vapor recovery proportional nozzles. Not a great deal of manufacturers in the UK currently that are doing stage 2 vapor recovery commercial pumps. And finally, the gauging system's got to be ATEX. It's quite specific with vapor recovery. The sensors that we used on this one are from OLE. It's a differential pressure system. Essentially, you have 2 sensors. One sits at the top of the tank and takes the pressure of the petrol vapor, and the other sits near the bottom of the tank and takes the pressure reading of the liquid. One subtracting from the other, I'm reliably informed, provides you with your differential reading, which gives you your literage and ullage calculations. So end product, there's a few photos taken here from handover and commissioning. This was all completed in July of this year. It's the biggest petrol installation on the commercial side that I've been involved with. And that is me done. So thanks for your time, and happy to answer any questions.
Thank you, Andrew. Thank you, Bert.
Thank you.
We have one question here, which is, have you guys had any experience with supplying marinas with petrol? And how does that differ from the kind of thing that you've done at Ocado, or is it similar?
Not personally, so I'll bat this one to Mr. Olive.
We have supplied petrol dispensers to some marina applications. Still, the similar principles still apply. You need to look at your DESIR risk assessment, whether you're using stage 2 or not. And that there is the added environmental requirement of having petrol on a water-based product, on a marina product. So yeah, there are applications out there, but it does need other considerations.
Okay. That's a really good point, actually, to hop on what Andrew said there about the individual requirements and DESIR risk assessments. I did a job at a golf club a few years ago, and that was required stage 1B vapor recovery, even though it was only about a 3,000 litre. So it's very much look at your environment settings around you and what the risks are. So they may be small capacities, but yeah, the environmental setting is key for decisions like that.
Okay, And that was the only question, which I think is good because we're now slightly behind. I think because we had so many questions previously and such good presentations. So, and to move on to the final presentation. Thanks very much to Bert and to Andrew.
Yeah, thank you very much, both of you, for doing the presentation. Very interesting. Yeah, meanwhile, our next presenter is Dylan Evans from the London Fire Brigade. Dylan is a research and inspecting officer at the London Fire Brigade's Petroleum Alternative Fuels Group. And in 2019, Dylan won the APEA Association, the APEA's Rising Star Award for work on the evolution of the fuel industry. So Dylan's focus has been alternative fuel developments and its impact on transport in the infrastructure. So Dylan, welcome, the floor is yours.
Hello, can you hear me?
Clearly.
Yeah.
Great. Can you see the screen all right?
Clearly.
First slide up. Okay. Yeah, as Anton has mentioned, my name's Dylan Evans. I'm a research and inspecting officer for London Fire Brigade's Petroleum and Alternative Fuels Group. My focus has indeed been on alternative fuel development and its impact on transport infrastructure. Today, I'm just going to provide an update on recent work regarding electric vehicles and their charging infrastructure from an inspection and enforcement perspective, but hopefully it should be of interest to site operators, installers, manufacturers in terms of what to be aware of and what petroleum inspectors are looking at. So in terms of background, we've heard a bit about this already today. Alternative fuels have been in the ascendant for a number of years, but recently we have seen the number of electric vehicles grow at the most rapid rate in order to meet emissions targets, such as the UK's commitment to net zero carbon emissions by 2050. And in addition to this, the PM announced on the 18th of November the government's 10-point plan for a green industrial revolution. I believe it was point 4 of the plan, which included a ban on the sale of new petrol and diesel cars by 2030, with the small exception of some of the cleaner hybrids. So in order to meet these targets, electric vehicles, specifically lithium-ion battery electric vehicles, are becoming an increasingly familiar sight on our driveways, places of work, inner cities, and of course, our forecourts. So the co-location of electric vehicle charging facilities alongside petroleum storage and dispensing equipment on forecourts represents the latest challenge for petroleum enforcement authorities due to the ignition risk that charging equipment could potentially cause. So as we've seen earlier, I think in Claire's initial presentation, the IET in conjunction with the APEA have published guidance on this. And while much of the supplementary guidance is geared towards the more technical aspects of electric charging, I'm going to provide an overview from an inspection and enforcement perspective, starting with the known risks. Now, many of the risks associated with lithium-ion battery electric vehicles are reasonably well documented. They may not be particularly well understood quite yet, but I'm going to list the main ones in order to provide a sort of context when looking at mitigation measures. So first and foremost then, key danger here is a process called thermal runaway, which is essentially the rapid buildup of heat in the lithium-ion battery, which can lead to flames venting and jetting out of the battery casing, burning debris under pressure, being ejected from the battery, and possibly even explosion. Thermal runaway is caused by a number of things, such as battery impact, under or overcharging, and possibly defects during the manufacture process. One of the main problems with thermal runaway is that it is very hard to predict, and equally, it is very hard to extinguish as well. It is a very different type of fire when you compare it with something like a petrol or diesel fire. Toxicity is another risk. So when a lithium ion battery burns, it releases plumes of, initially at least, lots of white smoke. Now, traditionally, white smoke has been associated with steam and therefore not seen as quite as dangerous. Unfortunately, this is not the case with lithium ion batteries, as this particular smoke may contain highly toxic chemicals such as hydrogen fluoride, hydrogen chloride, carbon monoxide, and a whole host of other horrible things that will require decontamination afterwards. Due to the nature of the fire, thermal runaway requires significant cooling, and that currently is done by pouring copious amounts of water onto the fire, which produces a considerable amount of runoff or wastewater from the extinguishing process. So large volumes of water are required to cool the battery, typically in excess of 20,000 litres for a medium-sized electric vehicle. Now, a consideration is that on a forecourt, this has the potential to overwhelm the drainage systems. The runoff would also be mixed in with toxic compounds, so it could also represent a risk to the environment if not properly contained. The fourth and final main risk is the risk of reignition. And lithium ion batteries have this peculiar property where they have the potential to reignite hours or even days after the initial ignition process. This is due to what's known as stranded energy. In other words, the energy trapped inside the battery, and because of deformation or burning, it can't go anywhere. So it's stuck inside the material. This poses a risk for first responders, as it is difficult to know whether the battery is fully extinguished. And similarly, a risk for secondary responders, those who have the task of recovering and transporting and possibly disposing of the vehicle. So those are the risks associated with the vehicle itself. Now onto the risk of the actual infrastructure, the charging cabinets, etc., on the forecourt itself. Now, due to the relatively high voltages involved, the charging equipment introduces a potential ignition source. For example, some charging installations require a substation to provide power. Should a fault occur with such a system, there is a risk that the current could go to ground or find an alternative route, go somewhere it shouldn't go, and potentially into ground penetrating conductors such as light posts, metal stanchions, or signage or similar. This could create the risk of electric shock or possibly an ignition risk should electrical arcing occur within a hazardous zone, depending on the nature and the structure of the site. So those are the risks associated with the whole charging process and on a forecourt. The next slide deals with risk mitigation and how to try and mitigate against them from a petroleum inspector's point of view. And the first thing to establish, as with petroleum hazardous zones, is safety distances. So the safety distance around a charging equipment, the electrical energy within charging equipment has the potential to cause a spark, therefore no part of the installation can be within a hazardous zone. This includes the length of an electric vehicle, plus the length of the charging cable at full extension from the cabinet. And this aims to mitigate against the risk of a spark reaching the hazardous zones. Also, charging cables should be tethered to the charging cabinet, thereby removing the option of custom-made cables of unknown lengths, unknown quality, unknown condition being attached. On top of that, a ground survey should be conducted. It's recommended that one is carried out to assess the site's soil resistivity, how far potential current could travel, how conductive the soil is. This needs to be carried out for each site due to variances in the compositions of the soil, at each different location. Now, this allows contractors to determine the appropriate level of electrical earthing required for the charging equipment to mitigate against the risk of ground penetrating conductors potentially becoming live should there be an electrical fault. And as always, such equipment should be installed by a suitably qualified, competent person. The other thing to consider when mitigating risk on a forecourt is the gradient. So forecourt gradients are designed so that fuel falls or flows towards some form of interceptor. So consideration should be given as to whether the charging equipment is located in a place where petroleum vapor may gather due to the gradient of the forecourt. The danger is a potential atmosphere could form around or near the base of the charging equipment. And on that, it's not acceptable as a fix to simply just raise the charging equipment onto some kind of concrete plinth or something like that, because it doesn't take the flammable atmosphere away. It would still gather there. Now we've got quite a mix onto the forecourt, so there needs to be a delineation of sort of enforcement duties. So now let's see who does what in terms of regulation and enforcement. So there's a statutory overview of the main pieces of legislation involved here. The electric vehicle charging equipment is predominantly regulated by the Electricity at Work Regulations 1989. Environmental health officers are the enforcers for these regulations. However, it is important for petroleum inspectors to have an awareness of the charging equipment due to the aforementioned risks that could impact upon the petroleum installation in relation to DSEER, dangerous substances, explosive atmospheres regulations. Also, installing electric vehicle charging facilities does not constitute a prescribed material change as detailed in the PCR 2014. Therefore, there is no statutory obligation for site operators to inform the Petroleum Enforcement Authority of the installation of electric vehicle charging equipment. However, it is good practice for site operators to inform their local Petroleum Enforcement Authority of such changes so that we are aware of it and so that our crews know what to expect when they turn up, should there be an incident. Now, hopefully the next few slides should be of interest to site operators, installers, manufacturers, as it does explain what, as inspectors, we are looking for and looking at. So, when a petroleum inspector encounters charging equipment, electric vehicle charging equipment installation during an audit, they should check for the following in order to mitigate against the aforementioned risks. Under no circumstances should the electric vehicle charging equipment be located within or encroach upon petroleum hazardous zones. If this is the case, then the inspector or the authority may take enforcement action under DSEER Regulation 7, places where explosive atmospheres may occur. The site's risk assessment should also take into full account all safety protocols and risk mitigation methods regarding the charging equipment infrastructure. If the charging equipment is not adequately addressed in the risk assessment, then the authority can take enforcement action under DSEER Regulation 5, simply risk assessment. All site staff should be provided with information and training on the appropriate precautions and actions to be taken to safeguard themselves and others from potential risks posed by this technology, as well as the impact it may have on the petroleum infrastructure. And failure to comply here would contravene DSEER Regulation 9, information training and instruction of employees. Also, we would be looking at the provision of emergency stop switches, which should isolate the petroleum dispensing infrastructure and de-energize the charging equipment. Failure to comply would contravene DESIR Regulation 8, arrangements to deal with accidents and emergencies. And another key part of our work regarding this is to also review plans, proposals to install charging equipment on existing sites. So sites with a petroleum storage certificate already issued. Now it's good that we get engaged at this early stage because it gives us an opportunity to provide advice early on in terms of how the equipment may impact upon the forecourt in terms of DESIR. So with a storage certificate already in place, an inspector cannot formally accept or reject the plans, but would consider the following. So what we've already mentioned, which is the safety distances, the training, risk assessment, etc. We'd also look for evidence that a ground survey has been carried out by a competent person. We check that the proposed installation doesn't adversely affect something like the means of escape or the muster points. We'd consider the gradient of the forecourt to ensure that flammable atmospheres do not form or pool near the proposed location of the new charging equipment. Also, we check the primary authority register to see if the site is in primary authority partnership for environmental health. Now, should the plans be non-compliant, the petroleum inspector will then contact the responsible environmental health officer and explain how the proposed or how the proposal appears to contravene the Electricity at Work Regulations 1989. I think it's specifically Regulation 6D, and communicate that with them and begin a dialogue. And other than that, on a site where a certificate already exists, the petroleum inspector can provide a response to submissions where they can give advice. However, as mentioned, it's important to remember that as a certificate is already in place, petroleum inspector cannot accept or reject the plans, just, as I said, provide advice. And on that, thank you for listening. Are there any questions?
Good, thank you very much for a very interesting presentation.
Thank you.
I just wait for Alex to come back up.
Hello, everybody. Very interesting. One question has come in, Dylan. You mentioned there the quite staggering amount of water it takes to put out a battery fire on a medium-sized car. I think you said 20,000 litres of water to put out a battery fire.
Yes, that's based on a model, Tesla Model S, I believe, a sort of typical sort of saloon car.
So, and if that fire, the question is, if that fire is to occur on a petrol station, and the fire brigade are called and are using that amount of water, could there be implications for drainage and the fuel interceptor on site?
Yes, I suppose the implication would be that it could overflow. I suppose it all depends on what type of system they've got in place, what kind of capacity was there originally before the incident, but you'd have to look at each site individually, I suppose.
Because I guess if it's water that's coming off, that should flow through the interceptor without necessarily allowing any oil to be released. But if it's water with a mix of other chemicals that are heavy, they could, in theory, fill the interceptor, and you could have runoff out into mains drainage, which might be something.
Yeah, well, this is it, I suppose. Even if it does pass through, the toxins will still get out somewhere, and it's whether they can be contained within the curtilage of the forecourt. but it's not a great chemical mix, that's for sure.
I can imagine. Another question we had here is there an awareness and a guidance to cover the standalone or banks of cooling towers which are used to reduce heat from high-speed charging installations? Do you know that?
No, I've heard of them. Sorry, can I have the question again? I must admit, I'll have to take this question away with me because I've not had any dealings with these at all. I've heard about them also in hydrogen installations where they could speed up the rate of dispensing by cooling down the hydrogen. But no, I can take that away. Sorry, what was the question again?
The question is there an awareness and guidance to cover standalone or bank cooling towers used to reduce heat from high-speed chargers?
I will have to look into that one and get back to if you can forward their details on to me, I'll get back to them.
I certainly will, yeah. And that was it for questions, so thank you very much.
Thank you, guys.
Right, that brings to close, really, the APEA Eastern Branch webinar. I hope you've all found this as interesting as I know many others have. I don't know if there are any other questions outstanding, Alex, at all, or points that we need to deal with?
I think we've covered pretty much all of the questions that came in, and I have said to everybody via the chat feature that if there are requests for, if anybody wants to get in touch directly with speakers or to ask any further questions, they can email me directly. And yeah, hopefully we can get back to them promptly with any answers that they require.
So I think on that basis, we can close the event. We thank all of you for attending. We hope you found it very interesting.
One more question actually just come.
Yeah.
Is there a recommended type of fire extinguisher to use for an electric vehicle fire? Dylan?
Hello, hi, can you still hear me?
Yes.
Yeah.
This is a really tricky one. I think the short answer is probably no right now, because the trouble is with a lithium-ion battery is that it contains its own oxidation products. So even if you use extinguishers which are designed to work by depriving something of oxygen, it won't do anything. There are other arguments against something like a foam extinguisher, where what you can do is actually effectively insulate the heat even more inside the battery as the foam just coats it. And it also then impedes water landing on it should they then switch to using water, because you've got to just then dissipate all the foam. As far as I am aware, the best current way is cooling, and the way you do that is with copious amounts of water.
Okay, interesting. Thank you.
Okay. Good. So then a final thank you to all the speakers and to all of you for attending our webinar. And yes, that concludes today's session. I don't know if you want to add anything to that, Alex, apart from wishing everybody
just to extend my thanks, and also if there's any Eastern Branch members that want to attend the formalities of the Eastern Branch AGM, we'll be starting that. What time are we planning, Anton?
shortly.
Shortly, so pretty much imminently.
There'll be a waiting room, so you can join us. We'll hang on for a bit anyway.
There's going to be it's a separate meeting. If you've registered, you should have the meeting details. So thank you all for attending, and have a great rest of the day.
Thank you. Thanks for the thumbs up.
Bye-bye.
Thank you. Bye bye.
Thank you very much. Cheers.
Bye.